Welcome back, ladies and gentlemen. In this video, we're going to work on verifying identities. And if you were to look at any textbook or any kind of notes online as far as verifying identities, you'll probably find these tips there. And they're very common, very similar tips that anybody would want to follow when you're verifying identities. However, I want to make sure that you are aware, just like all the other guides and tips that I provide in my process videos, not everything is perfectly step-by-step. Every problem is going to be a little bit unique. And sometimes you might have to do these a little bit out of order to be able to verify your identity. Now, again, our main goal, remember, is to make one side equal to the other side, or to show that both sides are equal to each other. So the first thing we're going to want to do is pick a side, and we're going to want to pick the side that's the most complicated, whatever we can do to verify it. Now, again, some things that I might do in this video might not be the way that you would want to do it. And again, my recommendation would be to try it. You can watch me do math problems all day long, but if you're not practicing on your own, it's going to be very difficult for you to be able to do this, to really understand how to do this, on your own. And it's very important also to remember that, it's okay. If I'd be able to do these on my first shot, that's because I have a lot of practice. I've done a lot of these problems. It might take you 3 or 4 times to be able to figure out a problem, and that's perfectly okay. I'd rather you work through the problem and try different things than immediately just quit and go ahead and try to find the answer. All right, so keep on working through them. That is one of the last steps. Try, and try again. All right. And you can see, try it another way. Just keep on trying. So let's go and take a look at this one. One thing I noticed is whenever I have a squared, and especially like a squared minus 1, I'm automatically thinking Pythagorean identities. Okay. So I see that also this left-hand side has a fraction. Well, I don't want a fraction, right? If the right-hand side doesn't have a fraction, then I'm going to want to simplify this. So first thing I notice is I can rewrite this as a tangent squared of x minus 1 over a sine squared of x. Okay, and again, I'm just going to keep the equal sign equal to the right-hand side. I'm sorry, that's a tangent squared, not a tangent squared minus 1. All right, now remember, now I can rewrite the tangent squared as a sine squared of x over cosine squared of x all over a sine squared of x. Okay, now again, we want this to equal 1 plus tangent squared. Well, so therefore I need to get this sine squared off the denominator. So what I can do is I can multiply by the reciprocal, which is cosecant squared, or I can just rewrite as 1 over sine squared of x times 1 over sine squared of x. Okay. Now by multiplying this, that goes to 1, that goes to 1, that leaves me with a 1 over a cosine squared of x equals, now again, that's supposed to equal a secant squared of x. Now, again, you might say, well, secant squared of x, is that equal to 1 plus tangent squared of x? And yes, it is, because that is the Pythagorean identity. So we have a lot going on here, but you can see that that is now equal. So you can see there was a lot of work going on, right? We used the Pythagorean identity, then we simplified, we multiplied by the reciprocal for the fractions, we again used the reciprocal identity, and then we used the Pythagorean identity one more time. So there's a lot going on in that first problem. But you can see we showed that the left side is now equal to the right side. And I want you to notice too, I just focused on one side, right? I just stayed on that one side the whole time. I didn't try to go back and forth or apply operations, like didn't subtract a 1 from both sides or do anything crazy like that. We just stayed on one side at a time. Now in this next example, again, we're going to want to choose the left-hand side. You can see it's obviously more complicated than the right-hand side. And obviously I see the pi halves minus theta, that tells me the cofunction identity, and this tells me the even odd identity. So the cofunction of cosine is going to be sine of theta, and then this is going to give me a negative tangent of theta equals, again, we're trying to find a negative cosine of theta. So let's go ahead and rewrite cosine as the, using the quotient identity. So I could say sine of theta all over a negative sine of theta over cosine of theta. And again, we could just multiply by the reciprocal here, just kind of like I did on the other one. If I do that, cosine theta over sine of theta, you can think of that as like over 1, right? So those will all divide out, and that will divide out. So I have this negative here, right? So remember, oh, there's a negative right there. So we can just make sure when you multiply by the negative, you do that on the top and the bottom. And you can see here we get a negative cosine of theta is equal to. So again, in this case, you can see we're just applying our identities. When we find some identities, and then we're just using, the basic identities here. Now let's kind of get into some ones where we're going to use some identities as well as maybe like some operations here. So in this case, I'm going to want to just rewrite everything in terms of sines and cosines. Like if I know this left-hand side is going to equal to 1, I know there's going to be a lot of dividing out. So what I'm going to do is I'm just going to rewrite everything in terms of sines and cosines. So this would be cosine of x over sine of x. And you can see, yes, everything just divides out. So 1 is equal to 1. Done. In this case, again, same kind of thing. You could rewrite this as the sine of x over, 1 over the sine of x, right? Well, again, if I want to get rid of this 1 over sine of x in the denominator, I can just multiply by the reciprocal on the top and the bottom. And as long as you multiply by the same number on the top and the bottom, you're going to get a sine squared of x, which is equal to the right-hand side. Now over here, we have some more operations. You can see we have some multiplication, right? On the left-hand side, there's multiplication. On the right-hand side, there's not, or there is. But on the left-hand side, it's from binomials, right? So obviously, it's much easier to multiply this than to rewrite this as a product of two binomials. And remember, when we have two binomials, what we're going to want to do is use distributive property. So I'll distribute here, distribute there. So let's say 1 times 1 is 1 minus cosine of x. Let's see, plus secant of x. And then secant of x times a negative cosine of x is going to be a negative 1. Equals all right, so that equals to the right-hand side. Now, again, that didn't equal the right-hand side, though, yet, did it? But we see that these two are going down. All right, now, sine over cosine times sine, that just equals cosine. That's kind of interesting. Okay, so now another thing that I can do is I can go ahead and, well, why don't we combine these, right? So if I could rewrite this as a negative cosine of x plus a 1 over the cosine of x, right? So you could rewrite as a secant as 1 over cosine. So therefore, to get the common denominator, I multiply by cosine of x over a cosine of x on the top and the bottom. So therefore, it gives me a negative cosine squared of x plus 1, and this is all over a cosine of x. Okay, and so now we recognize that we have the Pythagorean relationship. Again, we have a squared term, plus 1. So again, think of those Pythagorean identities. So in this case, I can rewrite this as a sine squared of x over cosine of x is equal to. Now, you can rewrite this. Remember, the sine squared, we can think of this as a sine of x times a sine of x over a cosine of x, right? So we can group these together, right? So I don't need to write those all together. I can now rewrite this as a tangent of x times the sine of x equals. And you can see how that got verified. So I didn't really have a little extra space, so I wanted to make sure I could show that to you so you can see why and how I would go from there to there and how it works. In the next example, again, I think it's kind of obvious. You see this distributive property, so you're like, all right, well, let's apply the distributive property. One of the things I remember, like, students will be like, oh, I'm confused. I'm like, well, you have to apply distributive property, or at least, hopefully, just do it. So sine of x times cosine of x is 1, and sine times sine of x is going to be a sine squared of x equals cosine squared of x. Hopefully you recognize, again, over here, it's just the Pythagorean identity. Cosine squared of x. Done. All right, so now the next one, again, it can be kind of overwhelming. Students are like, all right, so I have fractions on the left-hand side that are combined, and on the right-hand side, they're, it's just 2 secant squared of x. But again, all right, so let's combine the left-hand side. Now, they look like they're the same denominator, or they're close to, but they're not exactly the same denominator. So we need to multiply by the common denominator, which in this case is going to be 1 minus sine of x times 1 plus sine of x. All right, so I'm going to multiply here, 1 plus sine of x, 1 plus sine of x. Okay, so in doing that, I get a 1 minus a sine of x. Don't really need the parentheses. Plus a 1 plus a sine of x all over. Now, we can go ahead and distribute this, right? So we could do this as a, let's multiply this out. So this would be 1 minus a sine squared of x. Okay. Now, obviously here you can see that negative sine of x plus sine of x just goes to 0, right? So that becomes a 2 over 1 minus sine squared of x. Well, we already did that, right? That's cosine squared. It's cosine squared of x equals. Now, obviously, we can use the reciprocal property to show that this is equal to 2 secant squared of x. Verified. The next one is we have an addition, right, of two functions on the left-hand side, and we don't have addition on the right-hand side. So what we're simply going to do here is we want to combine these. Now, to combine these, we're going to want to rewrite them as fractions because we can't combine a secant squared of x plus cosine squared of x, okay? But we can rewrite this as a 1 over a cosine squared of x plus a 1 over a sine squared of x. Okay, now to get common denominators, again, we're going to need to multiply by sine squared of x, cosine squared of x, cosine squared of x, okay? When doing that, I get a sine squared of x plus a cosine squared of x all over a sine squared of x times cosine squared of x. Okay, and then hopefully you recognize here, guys, that sine squared plus cosine squared is equal to 1 over a sine squared of x cosine squared of x. Now again, we're supposed to equal this to secant squared of x and cosecant squared of x. But again, notice these are just the reciprocals. So therefore, this is cosecant squared of x times secant squared of x equals. Now again, the order is off, but that's okay, right? 2 times 3 is the same as 3 times 2. So therefore, this is verified. All right, the next one. Now, a lot of times when you see these binomials, one thing I look at is, well, what happens if I multiply by the conjugate, right? And this is kind of important. If you multiply by 1 minus cosine of theta, that's going to produce, 1 minus cosine of theta. When you multiply by 1 minus cosine, that's going to give you the 1 minus cosine of theta in the numerator. That's what we want, right? Also, what's really important to understand here, again, you don't always have to do, you could do the left-hand side, but I want to switch it up. I'm going to work on the right-hand side. Because again, one thing I actually forgot to mention, if you look at this problem, they're basically the exact same problem, right? The left side and the right side, like not one is definitely more difficult than the other, right? So just roll with it. So now up top, I'm not going to distribute this because I know I want this 1 minus cosine of theta, right? So I'm just going to leave it there. And then over here, I'm going to distribute this to a 1 minus cosine squared of theta, which automatically that tells me, oh, that's again another Pythagorean identity. That's going to be your sine squared, right? And then you can say, oh, well, those are going to go ahead and divide out, which just leaves me with a 1 minus cosine of theta over sine of theta. And there you go, has been verified. So let's do the same thing on the right-hand side. Let's work through this. So again, if we see, all right, well, let's multiply by the conjugate here. So let's multiply by a sine of x minus 1. Sine of x minus 1, right? Same kind of idea. We're just multiplying by the conjugate. So when you multiply by the conjugate, here we're going to get a sine squared of x minus 1 all over a cotangent squared of x. Again, we see that this is going to be a Pythagorean identity, but this one this time is going to be a cosine squared of x. This is x, not theta, right? Yep. All over a cotangent squared of x times a sine of x minus 1. Okay, so we have the sine of x minus 1. That's what we want, but we got to get rid of this cotangent squared. So we're going to multiply by the reciprocal, which is, yes, it is tangent squared, or you could think of this also as just being, cotangent squared. Remember, this is the same thing. I guess we'd have a little room. So why don't we rewrite this? So I have cosine squared of x all over. I could rewrite this as a cosine squared of x times a sine squared of x, right? Times a sine of x minus 1. So if I multiply this by the reciprocal, which would be a sine squared of x over a cosine squared of x, that would divide out, but then we'd be left with, but then we'd left over here, sine squared of x over cosine squared of x. Now these are going to divide out, leaving me with a negative sine squared of x all over a sine of x minus 1. Voila. So therefore you guys can see how it works both sides. So it's not always the case, when you have a difference, you're going to want to multiply by the conjugate, but I wanted you guys to see how that works out in that case. Because in this case, we could do this again, right? We could multiply by the conjugate. We could go through that whole process. But again, what I recognize here is like, why don't I just distribute this cosine, right? Why don't I just do this as 1 over cosine of x plus a sine of x over cosine of x, right? Because here I'm not trying to get a fraction. So that's why I'm working on the left-hand side, because I'd much rather like distribute this rather than trying to combine these two into one denominator. But you could do that as well. If you want to work on the right-hand side and combine them to one term, you get the same answer, obviously. So 1 over cosine, obviously here is secant of x, and sine over cosine is going to be tangent of x. And you can see that there, it has been verified. Here's another example of the right-hand side. And again, in this case, I'm going to want to, get rid of, I see this as I say, oh, that's going to be a cosine squared. So I have a cosine squared of x minus a cotangent squared of x, all divided by this can be rewritten as a cosine squared of x. Now, again, I can distribute the cosine squared of x into both terms. So that's going to be I'll just write it out because I got a little room, cosine squared of x over cosine squared of x minus a cotangent squared of x divided by cosine squared of x. All right, so that equals 1 minus. Now let's see here. If I was to multiply by 1 over cosine squared of x, all right, now that's going to give me a sine squared. Yep. No. That's cosine over sine. That's going to give me a cosecant squared, actually. Right? Because that's cosine over sine. So that's going to be a sine squared. No, 1 over sine squared. So it'll be 1 over. I think I wrote that down wrong. I made a mistake. That should be a cosecant. Right? Or hold on. We'll do this. So then this is equal to a 1 minus a cosecant squared. Maybe it's supposed to be cotangent. That's it. Okay, and 1 minus cosecant squared, if you think about that, that should be equal to, well, let's go ahead and write this out real quick. Sine squared of x plus cosine squared of x equals 1. And if you did cosine, that'd be divided by sine. So that's 1 plus cotangent squared of x equals 1. Nope, equals cosecant. So that'd be 1, so that equals a negative cotangent of x. There you go. So that's supposed to be a negative cotangent of x. All right. I made a mistake typing that in. But that's okay. We will move on from there. Sorry about that. So that should be a negative cotangent squared of x. All right. Unless I made a mistake, but I don't think I did. I did make some other mistakes I did catch when I was writing those in. All right. For the next one here. Now in this one, it looks like, well, I have two terms, but it looks like they have a common factor, right? And if they have a common factor, these are the last two, right? Yeah, last two. So if they have a common factor, let's factor them out. So if you factor out a secant squared of x, that's going to leave you with a tangent of x plus 1. That's supposed to be a tangent squared. A lot of errors here, so I apologize for that. And then a tangent squared plus 1 is going to equal a secant squared of x, which you can see here, that's going to equal a secant to the 4th of x, which is verified. Verified. Okay, and then the last one here is, again, let's go ahead and, they don't have the same power, so I can't subtract them. But what I can do is I can factor out a sine. Let's just work on the left-hand side. So let's factor out a sine, because they're basically the same, right? So if I factor out a sine squared, that's going to leave me with a 1 minus a sine squared of x. And sine squared of x is going to equal to a, okay, so a sine squared of x, that's equal to a cosine squared, right? And then I can rewrite a sine squared, right? That's equal to cosine squared. So a sine squared then is equal to 1 minus cosine squared. right? Well, now I can apply distributive property, so that becomes a cosine squared of x minus a cosine to the fourth of x. And you can see, voila, that has been verified. So there you go, ladies and gentlemen. That is how we verify our identities. You know, it's not always pretty. Sometimes you will kind of make some mistakes. Sometimes you will need to try some things over and over, but the main thing is to keep on trying. You know, a lot of times when you get stuck, convert things to sines and cosines. You know, always try to pick the side that is the most difficult and stay on that side. Look through all the operations and techniques that we've used in these last two chapters, and as well as look for the identities to be able to apply them. And I think once you get through that over and you get some problems, it will get easier and it will get faster for you. So otherwise, guys, that is it for this section. Go ahead and give yourself a shot at the Check Your Understanding quiz, and I'll see you guys in the next section. Cheers.